Welcome back to Go Figure. Today we are on lesson 37 of Saxon Algebra Half, Equations, Answers, and Solutions. Learning objectives today are to understand the vocabulary related to equations, to solve simple equations using inverse operations, and recall missing number problems that we learned in an earlier lesson. What is an equation? So an equation is a mathematical sentence. It shows two expressions that are equal. So early we learned about expressions being a string of numbers, variables, and operations. Well, an equation is when you have expressions on both sides of an equal sign. So you have two expressions equal to each other. And the parts of an equation are, you're going to have a variable, which is a letter representing a number. We learned that earlier. Constants, which is a fixed number, so just like the number 3 or 1.25. And also operations, plus, minus, times, divide. Later we'll get into powers and things like that. So we have true equations like 4 plus 2 equals 6. Now it's pretty obvious what this means as opposed to a false equation, 4 plus 2 equals 3. So the true equation is when both sides of your equal sign are the same. And a false equation is when it obviously is not the same. 4 plus 2 does not equal 3, so that is a false equation. And then we have what's called conditional equations, like x plus 4 equals 7. Now this is conditional because it depends what x equals on whether or not this is true or false. And a solution to an equation is a number that satisfies the equation or makes it true. So obviously 3, if x equals 3 in this equation, then that equation is true, which would be its solution. So the goal of solving an equation, we want to find the value of the variable that makes the equation true. And it should keep both sides of your equation balanced. So you can think of equations as sort of like a balance. That's not very flat, but imagine that was, parallel to the ground, where one side of your equation, one side of your equal sign, say 4 plus 2, and then on the other side you have 6, it's balanced, right? It's not like a teeter-totter or one side is up and the other one's down. They're even. So here's our first example. X plus 7 equals 15, obviously very simple. And this is like the missing number problems that we did early on in the course, where if you know 2 out of 3 of the numbers in a problem, you can figure out the third one. Obviously, x would be equal to 8 here. Because 8 plus 7 equals 15. Example 2, 641 minus y equals 453. So 641 minus something equals 453. A way we could solve this is just by taking 641 and subtracting 453 to figure out what y equals. So here we would have, we need to borrow a 10. So 11 minus 3 is 8. Then we need to borrow one of the hundreds, make that 13 minus 5 equals 8, and 5 minus 4 equals 1. So here y equals 188. And you can always check your answer, right, by substituting that value that you get for your variable and just see, does this actually work? If I do 641 minus 188, do we get 453? Let's see. Need to borrow here. 11 minus 8 is 3. Need to borrow again. 13 minus 8 is 5, and 5 minus 1 is 4, equals 453. So yes, that checks out. Third example, 2 ninths plus y equals 5 ninths. So yes, you will see fractions in your equations, but don't be scared about that. So obviously the answer here, y would equal 3/9 because we have common denominators and we're just adding up our numerators. 2 plus 3 equals 5. 3/9, which you could also reduce to 1/3. So very short lesson. Here's your practice problems. Just pause the video, quick answer those, and then we'll check your answers on the other side. Okay, x plus 6 equals 12. Obviously, x would equal 6 here. 6 plus 6 equals 12. And you want to get in the habit of writing your answers this way, where you're putting your variable here and you're equaling it to your solution. As we go forward in algebra, this is how you are going to be showing your answers. So just get used to writing that variable equals whatever your solution is. All right, next one, x minus 6 equals 12. Obviously, x here equals 18 because 18 minus 6 equals 12. And we could have remembered our inverse operations and used the solution, or what it equals, 12, and done the opposite operation plus 6 to get 18. Lastly, x minus 14 equals 6. So x here would be equal to 6 plus 14, which is 20. 20 minus 14 equals 6. Simple enough. So to review, when 2 of the 3 numbers are known in an equation, you can solve them just like the missing number problems that we learned in lesson 3. And then you can always check your answer by substitution. So just take your answer that you come up with, take your solution, put that in for the variable, and see, does your equation make sense? Is it true? All right, so your assignment is to do problem set 37 and then read lesson 38 in your textbook. Have a good day and see you next time.